Okay, so let's try the first one. So we have secant squared x times 1 minus sine squared. So secant squared is going to be 1 over cosine squared. Again, try to get everything to sines and cosines if you can. And then 1 minus sine squared, if you remember, cosine squared plus sine squared equals 1. So if I want 1 minus sine squared, this is one of those ones that I manipulated. So anywhere that you see a 1 minus sine squared, you can replace it with cosine squared and vice versa. So since I have a 1 minus sine squared, I'm going to replace that with cosine squared. And any whole number or whole expression you can put over 1. And your cosine squareds cancel, and you end up with 1. Okay, number 2, cosecant of theta divided by secant of theta. So again, I'm going to try to change everything to sines and cosines. So my cosecant is 1 over sine theta, and my secant is 1 over cosine theta. So again, I have a fraction within a fraction, so I'm going to copy dot flip it. So I'm going to copy the top fraction, change division to multiplication, and flip the bottom fraction. So 1 over sine times, flip this, cosine, oops. Make sure that you put your thetas or your x's in all of your problems. And then that's going to give me cosine theta over sine theta, and cosine theta over sine theta is cotangent of theta. So make sure that you memorize your identities. Number 3, 1 minus cosine squared over 1 plus cosine theta. So you have two options. When you have 1 minus cosine squared, you have the option of replacing this with sine squared. If I use sine squared over 1 plus cosine is not going to do me any good. Your other option, remember, is to factor. This is difference of squares, a squared minus b squared. So this factors to 1 minus cosine, 1 plus cosine. So anytime that you have difference of squares, you're going to have two options when you're doing these problems. And so in this case, this is going to help me more. So I'm going to change 1 minus cosine squared to 1 minus cosine and 1 plus cosine over 1 plus cosine. When I do that, as long as my factor is exactly the same, I can cancel it, and I'm left with 1 minus cosine theta. So you want to try to get it down to a single term if you can't. Sometimes if you have a 1 in it, that's fine, but get it down as low as it will go. Okay, next problem, we've got 4 is cotangent of pi over 2 minus x times cosine theta. So this is one of our cofunction identities, and if you look back in your notes, that is equal to tangent of theta, so or tangent of x in this case, times my cosine of x. And then we're going to change tangent of x to sine over cosine. You try to get everything to sines and cosines if you can. And again, I can put that cosine over 1. My cosines will cancel, and it reduces to sine. It's basically like a big puzzle. You have to figure out how to use all your identities and put them together. 5, cosecant of theta, tangent of theta, plus secant of theta. So again, I'm going to try to get everything to sines and cosines if I can. Cosecant is 1 over sine. Tangent is sine over cosine. And secant is 1 over cosine. So when I multiply these together, numerators, oops, it's supposed to be theta, it's not. Let me change these back to theta. Okay, so going back, my sines cancel, and I'm left with 1 over cosine of theta plus 1 over cosine of theta. As long as you have a common denominator, you can add these two together. That gives me 2 over cosine of theta. And you never want to have a fraction in your final answer And so this is the same thing as 2 times 1 over cosine. So that turns into 2 over this is secant. Oops, wrong way. Sorry, 2 secant of theta. Okay, next one, number 6. Sine of theta secant. Oops, I forgot the theta. So pretend there's a theta in there. Plus cosine theta, cosecant theta. So my sine of theta, I'm going to leave alone. So this is sine theta. Secant is 1 over cosine theta. Cosine theta, 1 over sine theta. So if I write these as one fraction, this is sine theta over cosine theta. This is cosine theta over sine theta. Again, since I've got 2 different denominators, I'm going to have to get common denominators. So that common denominator is going to be cosine theta, sine theta. Cosine theta, sine theta. So since I multiplied this denominator by sine, I need to multiply the numerator by sine. That gives me sine squared. Sine times sine is sine squared. This denominator, oops, this one here, the new thing in my denominator is a cosine. So if I multiply the denominator by cosine, I need to multiply the numerator by cosine, which gives me cosine squared. And when you put them together, you get sine squared theta plus cosine squared theta over cosine theta sine theta. This is one of your identities. Sine squared plus cosine squared is 1. So 1 over cosine theta sine theta basically gives me secant theta cosecant theta. And that's my final answer. Okay, number 7 is sine squared theta cosecant squared theta minus sine squared theta. So I'm going to leave sine squared theta by itself. You have a couple options when you're doing these. If you notice, you could just factor out the sine squared and then do cosecant squared minus 1. I'm going to instead change it to 1 over, change cosecant squared to 1 over sine squared. It doesn't matter which way you do it, you should end up with the same thing in the end. But I noticed that this sine squared will cancel with this one, which gives me 1 minus sine squared. And that, if you remember from your identities earlier on, your sine squared theta plus cosine squared theta is 1. So if I move this sine squared over, I get cosine squared theta equals 1 minus sine squared. So I can replace this 1 minus sine squared with cosine squared. And that is my final answer.